In this video, we are solving one IITJEE previous year question. This will help you understand the concept clearly and also learn the best way to approach similar problems in the exam. Let's get started. The question is x raised to the power 3 over 4 log x with base 2 whole square plus log x with base 2 minus 5 over 4 that is equal to root 2. We need to find x values here. In this question, the power of x is not simple. It's written in terms of log x with base 2. Whenever you see an expression like x raised to the power of f of log x, it usually becomes messy if you try to do directly. So, we use that logarithm property and you have to convert into exponential equation. You have to go and solve for the x. The logarithm property is log a with base b that is equal to n. So that means if we have a logarithm expression, if and only if, this we can write in terms of a exponential equation, that is a equal to b raised to the power of n. Here, if you assume a as root 2, b as x and n as 3 over 4 log x with base 2 whole square plus log x with base 2 minus 5 over 4. If you assume like this, substitute these a, b, n values in this logarithm property. Then we are going to get log a is root 2 and with base b is x. So that is equal to this whole expression n. So if we have a logarithm expression like this, so we can write this as a exponential expression, which is a equal to b raised to the power of n. So here our a is root 2, that is equal to b raised to the power of n. We assume b as x. So x raised to the power of n. n is 3 over 4 log x with base 2 and this whole term. Do you observe this is our original expression, isn't it? So using this logarithm property, this root 2 equal to x raised to the power of this whole term, we can write in terms of a log, which is log root 2 with base x, that is equal to 3 over 4 and this whole expression. So let's take this. Now observe only left hand side, which we have log root 2. Root 2 we can write it as, suppose if we have a root a, this we can write it as a raised to the power of 1 over 2. Similarly, root 2 also we can write it as 2 raised to the power of 1 over 2. So here we can write this as 2 raised to the power of 1 over 2. Now observe this log 2 raised to the power of 1 over 2. It is in the form of log a raised to the power of m. We can write this as m times log a. Use that property here. So we can write this log 2 raised to the power of 1 over 2. We can write this as 1 over 2 log 2 with base x, isn't it? So now observe the right hand side. We have a log x with base 2 and here also we have a log x with base 2. But in the left hand side we have log 2 with base x. So now I'm going to use one more property, that is change base property. So if we have a log a with base b, we can write this as 1 over log b with base a. So we can change like this using this change base property. So this log 2 with base x, we can write this as 1 over log x with base 2. So the left hand side turns into 1 over 2 log x with base 2. So the right hand side write as it is. Now in the left hand side we have a log x with base 2 and right hand side also we have a log x with base 2. All the terms it is in the form of log x with base 2. So each and every time write log x with base 2 is very difficult. That's why let us consider some variable as log x with base 2. Then this expression turns into 1 over 2a, that is equal to 3 over 4 log x with base 2 whole square, that is a power 2 plus a minus 5 over 4. Let's take LCM in the right hand side. So we have a 4. So it's going to get 3 a raised to the power of 2 plus 4a minus 5. In the left hand side we have 1 over 2a. Multiply both sides by 2. Then here 2 and here 2 gets cancelled and here 2 and here 4. So we are going to get 1 over a, that is equal to 3a raised to the power of 2 plus 4a minus 5 over 2. If you do cross multiply, then we are going to get 2 equal to 3a power 3 plus 4a power 2 minus 5a. So this we can write it as 3a power 3 plus 4a power 2 minus 5a minus 2, that is equal to 0. So we are getting here cubic equation. So we need to find a values here. By using hit and trial method, I am going to find a value. So let's substitute a as 1. Then we are going to get 3, 1 cube is nothing but 1, plus 4 a power 2 is nothing but 1, minus 5 times 1 which is 1, minus 2 that is equal to 0. So 3 plus 4 7, minus 5 minus 2 which gives 7. So you are going to get 0 here. So that means a equal to 1 is our first root. Using this root and long division method, I am going to find another two roots. For the long division method, we need to take only the coefficients of the a power 3, a power 2, a and this constant. So a power 3, the coefficient is 3, a power 2, the coefficient is 4, and a term, the coefficient is minus 5, constant is minus 2. So now our root is 1. So you have to take only 1. The first, what I have to do, bring it 3 as it is. Bring it down as it is. Then multiply diagonally. 1 times 3 is 3. So 4 plus 3 which gives 7. Then 1 times 7 is 7. So just write here 7. Then 7 minus 5 which gives plus 2. Then 1 times 2 which gives only plus 2. Minus 2 plus 2 which gives 0. So this is the constant term, and this is a coefficient, and this is a power 2 coefficient. So we are going to get here 3a power 2 plus 7a plus 2 that is equal to 0. So the cubic equation we convert into a quadratic equation. Let's take that and find the another two roots. To find these roots, what is the formula for the quadratic equation? Minus b plus or minus square root of b square minus 4ac by 2a. So here our a value is 3, which is a power 2 coefficient, and b value is 7 and constant is 2. So let's substitute here. So minus 7 plus or minus square root of b square, that is 7 square 49, minus 4 times a is 3 and c is 2. 4 3 is 12, 12 2 is 24. 49 minus 24 which gives 25. Square root of 25, the value is only 5, over 2 times a is 3, so 2 times 3 which gives 6. So this we can write as minus 7 plus 5 over 6. Another one is minus 7 minus 5 over 6. Minus 7 plus 5 which gives minus 2 over 6 is nothing but minus 1 over 3. And here minus 7 minus 5 which gives minus 12 over 6. After getting cancelled, we are going to get minus 2. So these are the another two values of a. First we have, first root is a is 1. So the a values are 1 minus 1 over 3 minus 2. We need to find x value here. At starting we assumed a as log x with base 2. So let's take that. So let's take first a as 1. So log x with base 2, that is equal to 1. Here we have to use one of the logarithm property, that is log a with base b, that is equal to n, if and only if a equal to b raised to power of n. Similarly here also, if and only if x equal to 2 raised to power of 1 is nothing but 2 only. So the first x value is 2, and then now we have to substitute minus 1 over 3. Log x with base 2, that is equal to minus 1 over 3. Using this same property, we are going to get x equal to 2 raised to power of minus 1 over 3. Now we have to take a as minus 2. Log x with base 2, that is equal to minus 2. Then x value is 2 raised to power of minus 2. This we can write it as 1 over 2 raised to power of 2. This value is 1 over 4. So the x values are 2, 2 raised to power of minus 1 over 3 and 1 over 4. If you like this content, don't forget to subscribe for more IIT JEE previous year questions. Solving previous year question daily will boost your problem solving skills and improve your exam preparation. Share with your friends who are preparing for the JEE. Thanks for watching.